All right, this is the continuation, the second video for lesson 1.5, and we're going to go ahead and take a look at multiplication. So I'm going to first do a multiplication problem on the way that I was taught way back, a long time ago, on how to do multiplication by hand, and then I'm going to show you another method that my kids learned in elementary school, and I'm like, this is so much better, and I think it's important to understand the difference between the two and how you wind up with the same result. So for this type of problem, you would first start, if we're doing multiplication, we're going to take this 5, and we're going to multiply it to the 6, and then we're going to multiply it to the 3. We're going to do it in one step at a time. 5 times 6 is 30, so I put the 0 here, and I have to put the 3 up here to remind myself this 3 is going to go into the next column. Now I do 5 times 3, which is 15, then I have to add the 3 to the 15, so we get 15, 16, 17, 18. So I'm going to put an 18 here. So I've multiplied the 5 to both of them. Now I have to do the 2. But notice, the 2 is in the second column. I mean, if we ignore the decimals, you could say this is like if this was 25, this would be the 20, this would be the 5. So it's almost like you're multiplying like a 20 versus a 2. And so we're going to put our answer in this column, starting in this second column. And one thing that a lot of people will do is put a 0 here to remind you that you don't put the values when you're multiplying the second number here. They have to start here. 2 times 6 is 12. I'll put the 2 down, and I'll carry the 1. Now I need to remember that I've already used the 3. That's gone. Right? That was in the first row. 2 times 3 is 6, plus 1 is 7. 0, 10, carry the 1, 9. And then, now that I'm done, I have to count up the decimals. Well, there's one number after the decimal and another number after the decimal, so a total of 2. So we're going to go ahead and put a period there. All right, awesome. That's our answer. So basically our answer is 9, and if we do that on our calculator, and we do 3.6 times 2.5, you get 9. Now, after doing this problem, I realized I don't need the decimals at all. I could have not put the decimals in, and it doesn't change my process. Like, if I just put 36 and 25, I would have gotten 900, and then I'd go back to my original problem and count decimals. So you don't even have to put decimals in there. But this problem, I'm going to show you another method. Since there are 2 digits in each number, I'm going to make a 2 by 2 box. 2 rows, 2 columns. So go ahead and draw that on your paper. All right. Once you have that, you're going to draw diagonals from the bottom left to the top right, just like I'm drawing. These are going to be really important. Once you've created this box, remember, you can pause the video at any time, so if you need a little extra time, pause it. I'm going to put the first number above it, so the 3 goes in the first column, above the first column, and the 6 goes above the second column. And then the 2.5, I'm going to put on the right side, the 2 at the end of the first row, and the 5 at the end of the second row. I'm not going to put the decimals in, because we'll deal with that at the end. Now, here's the beauty of this. We're going to do all the multiplications first. Remember how we had to put these 3 and remember to add them in and stuff? We don't have to do that in the same step with this. This is called the lattice method. The lattice method's pretty cool. So if we look at this box here, 6 is at the top, 5 is at the right. So we're basically doing 6 times 5, which is 30. Now when we did that, we put a 0 here, and we had to put the 3 up here. Here we just put it in the box. If we look at this, the 6 above it, the 2 to the right, 6 times 2 is 12. And you always put the numbers, if it's 2-digit, first digit here, second digit there. Right, let's go to this box. 3 at the top, 5 at the right. 3 times 5 is 15, so 1, 5. And then 3 times 2 is 6. Since it's only 1 digit, it goes in this bottom box. We leave that one empty. So we've done the multiplication, and I want to point out when we did this 2 times 6 and got the 12, we had to carry that 1 over. We don't have to worry about it. in this one. So we didn't have to worry about like putting these numbers up top and adding them as we're multiplying. Now we're going to do the addition as a separate step, and everything goes diagonally down. So 0 just becomes a 0. I'm going to add these three things, 5, 6, 7, 8, 9, 10. So I put a 0 here. So as the 10, I do have to carry that 1, so I'm going to put it up here. Then we have 6, 7, 8, 9. So notice how we counted that 1 here. And now we have our 900, right? And then we can look back at our original problem, say there were 2 decimals, so it is a 0.9. So this lattice method is really great. The 3 that we had to carry was already in here, right? So when we added these together, that's like having the 8 and the 2, right? But that would be the 8 and the 2. This became an 8 because when you did 5 times 3, you got your 15, and then you added the 3 to get the 8. Well, here, we're not doing that at the same step, so we're doing it separately. All right, so we're going to go and do the next one. I'm going to stick with this lattice method because I think it's so much simpler. Now, if you are used to the traditional method over here and you want to continue with that, that's fine. I have no issues with it. But I'm going to go ahead and use the lattice method because I do think it's a simpler process. The 48 goes on the top, and the 35 goes on the right. Same process again. 8 times 5 is 40. If I'm doing this box, it's 8 times 3, which is 24. If I'm doing this box, it's 4 times 3, which is 12. And if I'm doing this box, it's 4 times 5, which is 20. So I went ahead and just did my multiplication, and then we do our adding diagonal, right? This is a 0. The 4 plus 4 is going to give me an 8. These 3 2s are a 6, and that's a 1. So I have 1, 6, 8, 0. Count up decimals. 1, 2, 3. There are 3 numbers after the decimals. So that decimal goes there. So it is 1.680. And let's confirm that on our calculator. 4.8 times 0.35, 168. Now you'll notice the calculator didn't give you the 0. A 0 at the end doesn't change value, so the calculator will just drop it. I mean, it's not wrong to have it there. It's not incorrect, but it's not necessary for that answer. All right. So you have 2 examples here. Why don't you go ahead and pause the video and work these 2 examples, and then unpause when you're finished. I went ahead and just made the boxes for both of these problems. Now the first one's same type of box as the other ones because they're both 2-digit numbers, right? But here you have a 4-digit number, and this is a 1-digit number because we don't really count this 0. So this has a different size box. So it's going to have 4 columns and only 1 row. And so 4 numbers, 1 number, that's why. Let's go and do this one. So if this box is 2 times 7, which is 14, this box is 2 times 1, which is just a 2. We'd leave that blank, or you could put a 0 there if you want. 4 times 1 is 4. And for this box, it's 4 times 7, which is 28. And now that we've done all the multiplication, we do our addition diagonally. That's a 4, 8, 9, 10, 11. So we put our 1 there, and then we carry the other one up to the next diagonal row. 4, 5, 6, 7. So we get 7, 1, 4. And then we look at our decimals. 1, 2. There's 2 numbers after the decimal, so it must go here. Confirm on our calculator. 4.2, sorry, times 1.7. That is 7.14. All right. For this one, 5 times 4 is 20. 3 times 4 is 12. 2 times 4 is 8. And 1 times 4 is 4. And so this actually becomes quite simple. 0, add those, you get 4. Add those, you get 9. And a 4. That's your answer. So that one was nice and quick. Where does the decimal go? Well, there's 1 here, and there's 2 more numbers after a decimal here, so a total of 3. So we're going to have to put that decimal there. So we should get a 4.94. The calculator will not put the 0 on there. So 12.35 times 0.4. You can put 0.4 or 0.4 on the calculator. You don't have to necessarily have the 0.4. It treats it the same, and confirmed. That is our answer. All right. So I'm going to go ahead and end this video here on the multiplication. Please continue on to the division.